Hey guys, welcome back to another video. In today's video, we're going to talk about logistic regression. And some of you might think that logistic regression is used for regression, right? Since it has regression in the name. However, that is actually misleading. And we actually use logistic regression for classification. And in this video, I will be talking about how we can classify different things using logistic regression. And in order to understand this video, I suggest you to check out my video on linear regression if you haven't already. It's a good idea to know what linear regression is before learning a logistic regression. Alright, so let's jump right in. So, what is classification in machine learning? Well, classification is the process of predicting the class of given data points using a machine learning model. And that sounds a bit complicated, so let's see what I actually mean by this. Here's the image that I grabbed off of the internet, right? So how classification works is that first we're giving some labeled data. For example, here we have some images of apples and strawberries, and it's important to know that they're labeled, right? We label that those are apples or those are strawberries. And then we feed those label data into a machine learning model. And then the machine learning model trains on the label data, and then whenever we input some new images of apples or strawberries, it's able to classify them as either apples or strawberries. And in this case, for machine learning model, we will be using logistic regression. All right, let's see. So what is logistic regression used for? Well, like we said, logistic regression is used for classification, but mainly binary classification and multi-class classification, right? And if you don't know what binary classification means, it's basically classifying something as either yes or no, right? Or sometimes you might see a 1 or 0. They're the same thing. Okay, so let's see a binary classification example. So we're trying to predict whether someone or an animal is obese based on their weight. And here we're giving some data points, right? On the x-axis, we have some weight in kg, and on the y-axis, you see that it spans from 0 to 1. And 1 means that the person is obese, and 0 means that the person is not obese. So what we can see here is that the less you weigh, the less likely that you are obese. And so how do we fit a line, right? How do we fit something to the data so that we can predict whether someone is obese or not based on their weight? And if you watch my previous video, you might think that, oh, we can use a line here, right? Like linear regression. And if we plug in some points, it might work, right? And what you see, the blue line here is called the threshold, right? And typically it is around 0.5. So if, for example, your x value and y value are above this, then we have it is obese because it is above 0.5. So right, so if we're given a weight in kilograms, and then we can tell the probability of it being obese, right? So, and this 0.6 means 60% chance, right? And this line is the best fit line. If you don't know what the best fit line is, I highly suggest you to check out my linear regression video, right? Okay, so now we got that out of the way. So if we can just classify perfectly with a straight line, then why do we use logistic regression? Or what is logistic regression even used for if we can just use linear regression? Well, let's see a counter case. What if we had an outlier here, for example? Then our line will be different and it won't work as perfectly as before, right? So if we have a weight here, it should classify as obese, but the line changed. Now it classifies it as non-obese since it's below the 0.5 threshold, and now it's only 75%, 47% for obesity. Sorry. And so it classifies it as not obese, which is incorrect. So how do we fix this issue? Well, let's see how logistic regression solves this issue. Here you see that, hey, we don't have a line anymore, right? This is a curve. So why might we use a curve in this case? Well, as you can see, since it's not a line, it's not affected by outliers, right? If we have an outlier far to the right, it's not going to affect this function much, since it will eventually pretty much flatten out at the end. So this fits the data much better. So as if we have a weight here, we can predict it here, it will be correct. And sometimes you might have a data point here, and those are called outliers. It will be incorrect for those, but for these cases, it will be quite accurate, right? This will work pretty well. And yeah, and you might be wondering, what is this curve called? Well, in machine learning, in general, in math, this curve is called the sigmoid function, right? We'll see later how we can use math to get this sigmoid function. Alright, so how do we fit a curve to the data? Well, for this curve, we calculate the likelihood of each data point, and then we multiply them together. And we try to maximize the total likelihood. So what do I mean by that? For example, we have a data point here. We can get the weight here, and then we can use this curve to predict the likelihood. And we're trying to maximize this, right? We're getting this likelihood, we are multiplying it by the next likelihood, and then and we're trying to maximize the total likelihood. And let's see, we get some more lines, and then we repeat this step until we get the best sigmoid function, or the best curve, or the best squiggle, right? The best squiggle that maximizes the total likelihood. And in this case, what is it called? The C green line fits the data point the best. Okay, so let's look at some math for logistic regression. So let's first look at the linear model to represent the probability, right? So this is the linear model. This is actually really easy to interpret, even though we're seeing some Greek symbols here. It's not actually that difficult. This is the same thing as mx plus b, right? Or mx plus c, depending on where you're from. And where b is the y-intercept and m is the slope. And in this case, we're basically having the same thing, right? So it's not that complicated. And p of x is the probability. And if we go way back, we have a line here, and we can use this line to get the probability, right? Plug in an x, and then we can get the probability, which is the y, right? Oops, I jumped ahead, but yeah, let's see. And so this is the logistic function, right? The logistic function gives outputs between 0 and 1 for all values of x. So that's what the probability is, right? And that's the curve we were seeing here. This is the curve we're seeing here. And if you notice, we have some universal constants. In this case, we have Euler's number, E, and it's e to the power of mx plus b, right? So that is the linear model we have here. And so why is this the case? Oh, by the way, this is in vectorized form. If you're wondering, this is x is not a single a scalar, as you can see. Yeah, x is not a scalar. It has all the x values. Okay. Yeah, it's basically the how do you say? Yeah. Anyways, moving on. This is basically e to the mx plus b, right? In simple terms, we ignore the Greek symbols, and so you might be wondering, why is it e to the dot, and what is e? Well, I don't think it's quite important to get into the details. E is just a universal constant. You can say it's around 2.7, somewhere there, and the universe has constants, so it's not that big of a deal, right? And yeah, this is the logistic function. It's actually quite simple, but the math for logistic regression, more advanced, can get quite difficult. So I think this video will just be sort of an introduction to logistic regression, because I feel like it's more important to get down the concepts, but the math can come later, right? Okay, so, and yeah, that's all you have to know how logistic regression works on a basic level. So now let's get in some coding. Let's end show. And here I have a Colab notebook. It's currently empty, but we're going to use a data set, right? So let's name this logistic regression. Logistic regression simple, right? Okay, let's add a code. Yeah, let's get the data set first. We can upload. It's fine. Okay. Rename this. I don't know why it's called insurance. It should be insurance data. Yeah, I got this simple data set here, but first let's import the libraries that we need. Import pandas as pd, import numpy as np, import matplotlib.pyplot as plt, import cborn as sns and set theme style equal dark grid. So we're just importing the libraries that we need. If you're not familiar with any of these, I highly suggest you to learn them before machine learning. For these, you can actually learn them from Kaggle directly. Kaggle has some great courses that I highly recommend you to check them out. In fact, let's see them together. Courses, you can go to Kaggle courses, and as all of these, I highly suggest you to take the pandas one, the machine learning ones. These are great. You can pretty much get hands-on first. So yeah, and you also got SQL and a lot of these actually. It has a data visualization. Yeah, this one is for Seaborn and Matplotlib, so you should definitely take this one. Yeah, so let's get started. We imported our libraries, And now let's load in our data set, right? So data set, data frame equal pd.read CSV, and our data set name is called insurance data.csv. Now let's see our data. As you can see, it's very simple. We're just using the age to predict whether someone has bought insurance or not. Okay, so how might we use this data? Well, let's try to visualize it, right? As the scatter plot, x is equal to age, y is equal to bought insurance. Oh, hold on. Bought insurance, right? And our data is equal to data df, right? Beautiful, right? So you see, this sort of resembles our logistic regression data set that we had in this slideshow, right? You can somehow visualize like a sigmoid function here. Yes, a sigmoid function here. Yeah, this is what we have. Awesome. Alright, so let's see how we can use logistic regression here. So let's first split our data into x and y. Cool. So in the x we have x equal df, and our x is called age, and y equal df bought insurance, right? X is the feature or the independent variables, y is the dependent variable. Okay, and if you're wondering, here 0 and 1, this is binary classification, right? 0 means yes, they bought insurance. 1 means 0 means no, they didn't buy insurance. 1 means yes, they bought insurance, right? In computer, 0 means off and 1 means on. Alright, so let's see. Let's see our x and y display. And display is actually very cool. It pretty much is the same as the print function, but it allows you to visualize the data set in pandas data frame. So I usually avoid using print if I can just use display, right? So we gotta split our data set into train and test data, right? So I'll explain why. Split data into training and test. Alright, so how you do this is you import from scikit-learn, right? From sklearn model selection, I believe. Yeah, import train test split. Boom. Okay. Yeah. If you don't know how to code this, it's fine because I code this hundreds of times, so I pretty much memorized this. But if you're a beginner and you aren't sure how to memorize these things, just practice a lot and you'll definitely memorize them. Alright, so now let's get in x train, x test, y train, y test equal train test split x and y. And let's see, our test size is 0.2, random state equal 42. So what I've done here is that we have our x train or our x training set, and we have x test or the x testing set, and y train and y test. So why do we need a training set and a testing set? Well, training set is for training the model. Testing set is for testing how well our model performs, right? So we use a training set to to train the model and then test the model using our testing set. So let's see how we can do that. From sklearn.linear, is it linear? Yeah, linear model, import logistic regression. And then we do model equal logistic regression. Model.fit, we're fitting the X train and Y train. That's what we're training our model on. X train's not, oh, I didn't run this, my bad. Yep, this is working now. So how can we evaluate how well our model runs? Well, we can use model.score X test, Y test, and we get a score of 1, which means our model worked perfectly. And this is because we had a really small data set, right? Typically in machine learning, it will be working with thousands, hundreds of thousands, millions of data. So, and here we only have like 26, which is really small amount. So this is why it predicted perfectly. But as you can see, this is actually very powerful, right? We're able to predict it perfectly. And yeah, this is how you can implement logistic regression in scikit-learn. Now, if you're doing an end-to-end project, there are probably a lot more steps since you have a lot more features. And this is just a simple data set, like really simple data set. We only have one feature here, which is age. Typically, you'll have tens, hundreds of features. So this is actually very simple. So let's go back and explain what this is. Train test split is basically a scikit-learn function that allows us to split our independent variables and dependent variables into training and testing. And the test size is how large our testing data should be, right? In this case, the testing size is 20% of all of our data. So X train is 80% of the data, X test is 20% of the X, right? And random state equal 42 is just so that we don't generate different X train and X test and all these stuff every time we run this code. And you might be wondering why 42? Well, it's just it's a funny number. It's the answer to the universe, some mathematicians might say. Alright, so that's it. And if you're wondering, you can actually do model.predict X test. Right? See, we're seeing that it's predicting the X test here. And let's see our Y test. And it's the same thing, which is really working perfectly. Yeah, awesome, cool. And I think this is all you have to know for logistic regression. So if you guys found this video helpful, please leave a like, and I'll see you next time. Oh yeah, and also comment down below whether you enjoyed this style of teaching or you prefer me working with whiteboards more, because I'm testing different styles of teaching. I'm hoping I can get some feedback so I can improve my future videos. That would be fantastic. And yeah, I am planning on doing some deep learning videos, hopefully. Deep learning is very fun, and if you know logistic regression and linear regression already, you can find them very helpful for deep learning as well. Or I might do some further machine learning videos, right? Maybe I can do some decision trees or random forests. I don't know. It's up to you guys. Please comment down below on what you guys want to watch. And yeah, I will see you guys next time. Bye.